Hey guys, I wanted to create a quick video about percent increases and decreases and writing equations to help us solve those, to help us through the homework that we have tonight, and if you still have some points of confusion from the classwork we've been doing. So follow along as I go through screens 4 and screens 5 from January 20th's classwork assignment. So let's read the problem together. Money in a particular savings account increases by about 8% after a year. If the amount of money increases by 8%, what percent of the original amount do you have, right? And when we talk about original amounts, that's kind of like our starting point. Like, where are we starting? Okay? And when we're talking about percents, we are always starting at 100%. Okay? We start at 100%. Let's make this a little bit thicker. And we're noticing an increase of 8%. So it increases by 8%. Okay? We should know that increase always means to add. Okay? We're going to get bigger. And a decrease means we're taking away, so we're subtracting. It's going to get smaller, okay? So when it's an increase, we add. When it's a decrease, we're subtracting. So basically what's happening here is we're starting at 100% and we're adding 8% because we're increasing by 8%. So our ending percent, the percent of the original amount, is 108%. Right? It's 108%. Now let's write that percent as a fraction, and this is a skill that you can do on IXL, okay? Writing percents as fractions, as decimals, and going between the three of them. When we're dealing with percents, the denominator is always 100. It never changes, okay? Percents are always out of 100, okay? So that would be 108 as a fraction. And as a decimal, 108 is 1.08, or 1 800. And a trick that we can use for this, that perhaps that you learned in 5th grade, is when we take a percent and we want the decimal, we just move that decimal over 2 places, okay? Because remember that there's always a decimal after a whole number. We might not always write it, but it's there. So we move it over 2 places. Okay, so these are 3 ways, 1, 2, 3, to represent a percent. 108% is the same as 108 over 100, which is also the same as 1.08, or 1 800. So now we can write an equation for this situation. And writing equations make us very efficient mathematicians. We can answer these problems pretty quickly once we develop an equation for this percent increase situation. Every equation has a y, an equal sign, and an x, okay? This problem here is telling me that x is the initial amount, okay? So there's all my x's. We also know that y is the final amount, okay? So this is my x, this is my y. What goes between the equal sign and the x, the blank mark, is that percent. It's the percent as a decimal. Not 108, but as a decimal. That's what goes there. The percent of the original amount as a decimal. This tells me that the final amount will always equal 1.08, or 1 800 times the initial amount. Because when we have a number next to a variable, so we have a coefficient, and we have a variable, when they're next to each other, that means to multiply. So this kind of reminds me of constants of proportionality, right? To get y, I can just multiply x, whatever the value of x is, whatever the initial amount is, by 1.08. So for example, if the initial amount is 100, right, and I want to find final amount, I can do y equals 1.08. I can use this equation and just wrote up times that initial amount, and this initial amount is 100 because x represents the initial amount. So 1.08 times 100 is 108, right? So the pattern that we're seeing here is we can just take that initial amount and multiply by 1.08. Now, our initial amount is 50. We can do the same thing. We don't know what the final amount is. We don't know what y is, but we do know that the initial amount is 50 and the initial amount is x. So I can take 1.08 and multiply times 50. Okay. When I do this, I get 54. So this means if I start with $50 in my account, after the year I gain 8%. There's an 8% increase, so then I would have $54 left. If I start with $100 in my account and there's an 8% increase, okay, which means I have 108% of my original amount, I would have $108. And then lastly, if I have $500, we find the same pattern. We can multiply by 1.08 or 1 in 800ths, and 500 times 1.08 would be 540, which means if I start with $500 in my account, I increase it by 8%, I would have $540 left in that account. Alrighty, so that was an example for a percent increase. Let's check out a percent decrease problem. The value of a car, so I'm now looking at screen 5 from January 20th, Desmos. The value of a car, new car, decreases by 10% in the first year. Okay? Remember that a decrease means that we are subtracting. Okay, that key word, if it's a decrease, we're subtracting. So we have our starting point. We always start at 100%. What's happening to this original amount? Well, we seem to be decreasing it by 10%. So then we want to figure out, well, what percent of the original value do you have? So the original value is this 100%. So original value is the 100%. And then we decrease it by 10%. We take a decrease of 10%. And when we do that, we're subtracting. So we're left with 90%. So 90% represents the percent of the original value. We can write this as a fraction. It would be 90 over 100, because anytime that we're dealing with fractions and percents, 100 is always the denominator. And if we were to write this percent as a decimal, we move that decimal place 2 to the left, 2 places to the left, and we're left with 0.90. Or you can notice that 90 divided by 100 is 0.9. These actually equal to each other, right? Because these are all the same. 90% is the same as 90 over 100, or 90 100ths is equal to 0.9 or 99 hundredths, right? Not 9 hundredths, I'm sorry, 9/10. Silly. 90 over 100 is the same as 9/10. Okay. So then we want to write an equation for this situation where x is the initial value, right? So we have x is the initial value, and we know that y is the final value. So we can write it like this: y equals something times x. And that something that goes right here is always the percent. But be careful, it's not 90. We have to make it the percent as a decimal. So it would be 0.90. You have to use the one that is the percent as a decimal, not 90. Okay, so some relationships that we should be seeing here. We know that this is our y values. initial is our x value. So what this is saying right here is that the final value of the car equals 90% of the initial value of the car, or the final value equals 0.9 times x, because when we have a number, a coefficient, next to the variable, okay, that means to multiply. So again, we notice some patterns here. We have 1,000, we want to get to the final value. We can just use substitution if you want. We don't know what the final value is, so we don't know what y is, because the blues match up, the y value is the final value. But we do know that the green x, right, the greens, the x value is 1,000. So I could do 0.9 times 1,000 and see that that's 900. So I'm multiplying by 0.9, right? Same thing over here. We can multiply this 1,500 times 0.9, which is 1,350. And of course you can use a calculator. I strongly encourage you to use the tools that you have access to. So figuring out what that percent of the original you have is imperative, which means really important. Then you need to write it as a decimal, like we did here. Substitute that into equations, and then we can solve, because the pattern doesn't break. Each time we're taking that initial value and we're multiplying by 0.9. And it makes us more efficient mathematicians. We can finish that a lot